Throughout this presentation, you will develop an understanding of different properties of the atmosphere that determine global climate and local weather patterns. As we previously learned, all atmospheric gases have mass. As Earth's gravity pulls the gases towards its surface, the weight of these gases presses down on the air below. Because the molecules nearer the Earth's surface are closer together, the air is denser and exerts a greater force. This force is known as air pressure. Air pressure is greater near Earth's surface and decreases with increased altitude. Air pressure is not constant. Average air pressure at sea level is 1,013.25 millibars, which is the same thing as 14.6 psi. Areas in which air pressure steadily increases are known as high pressure centers, and areas in which air pressure steadily decreases are known as low pressure centers. Low pressure centers are zones of convergence where winds spiral upward and flow counterclockwise in the northern hemisphere. The resulting weather system is called a cyclone. These are generally associated with cloudy, possibly stormy weather. Tornadoes and hurricanes are considered strong cyclonic storms. High pressure centers are characterized by zones of divergence where winds spiral downward and flow clockwise in the northern hemisphere. The resulting weather system is called an anticyclone and is associated with good weather, clear skies with cooler, drier air. Wind is a horizontal movement of air that results of the uneven heating of Earth's surface. The heated air at the equator is less dense, so it is replaced by denser, colder air, creating convection currents. This cold, denser air comes from the poles, which receives less radiation from the sun, making air at the poles much cooler. The resulting dense, high-pressure air sinks and moves along Earth's surface. The rotation of the Earth causes moving air and water to appear to curve to the right, north of the equator, and to the left, south of the equator. The flow of air caused by the difference in the amount of solar radiation received and by the Coriolis effect create distinct wind patterns on Earth's surface. Here's a quick animation to illustrate the Coriolis effect. In the top example, a plane flying from Anchorage, Alaska directly toward Miami, Florida, would miss its target due to the Coriolis effect. The target location where the plane was headed when it took off has moved with the Earth's rotation, so the plane would end up to the right of its original target. The second example is a plane flying from Tierra del Fuego in Argentina directly toward Rio de Janeiro, Brazil, and it would miss its target due to the Coriolis effect. The target location where the plane was headed when it took off has moved with the Earth's rotation, so the plane would end up to the left of its original target. In reality, pilots take the Coriolis effect into account so they do not miss their targets. Early sailors discovered that wind patterns on Earth helped them navigate the oceans. Sometimes sailors found little or no wind to move their sailing ships near the equator. This windless, rainy zone near the equator is called the doldrums. Air descending to Earth's surface near 30 degrees north and south latitude creates steady winds that blow in tropical regions. These are called the trade winds because early sailors used their dependability to establish trade routes. Between 30 degrees and 60 degrees latitude, winds called the prevailing westerlies blow in the opposite direction from the trade winds. Prevailing westerlies are responsible for much of the movement of weather across North America. Polar easterlies are found near the poles between 60 degrees and 90 degrees latitude and blow from the east towards the west. Global wind systems determine the major weather patterns for the entire planet, and smaller wind systems affect local weather. If you live near a large body of water, you're familiar with two such wind systems: sea breezes and land breezes. A sea breeze is created during the day because solar radiation warms the land faster than the water. Air over the land is heated by conduction. This heated air is less dense and has lower pressure. Cooler, denser air over the water has higher pressure and flows towards the warmer, less dense air. A convection current is created and wind blows from the sea toward the land. The reverse occurs at night when the land cools quicker than the water. Air over the land becomes cooler and the air over the ocean. Cooler, denser air above the land moves out over the water as the warm air over the water rises. Movement of air toward the water from the land is called a land breeze.